In this problem, it asks, what value of a would make this piecewise function continuous? Now remember, continuous, what I mean by that is, if you have a function, say it's this, a piecewise function, or any function, can I draw it without picking up my pen? With this function, I happen to be able to draw the full thing without picking up my pen. So I want to know, at boundary points, is it connected like the green graph, or is there some kind of disconnect at a boundary point? All right? So I want to understand these boundary points. In this instance, the boundary point, all right, the point where the function shifts from one function to the next, is -2. Okay? So I need to know, at -2, if I plug in the x value of -2, is it going to give me the same y value out? With things that aren't continuous, okay, they're going to have different y values. This function has a y value of whatever this is, of y1, and here it is y2, okay? So I want to know if the y value is going to be the same for both. If it is, then that function is continuous at that boundary point. If it's not, then it's not continuous. So let's plug in -2 for both, okay? Now, a function, right? We have, this function, any function, y is equal to x plus 1. You input an x, and the output is going to be y, right? So, with these problems, this is our output is essentially either 3x squared plus 4 or 5x plus a. Those are our outputs. Our inputs are our x values. So I want to set my y values, or in other words, these, equal to each other. And also plug in that specific boundary point. So I'm going to set this up like this. I'm going to put my boundary point in and set these y values. Remember, this is y, and this y has to be the same. This is the y for the other piece of the piecewise function. Okay, and then we're going to just solve. So what do we have here? We have a 4, a 12, and a 16 on the left. On the right, we have a -10 plus a. I'll add 10 to both sides, and we know that a has to be 26. So this number has to be a 26 in order for this function, this piecewise function, to be continuous at the point -2, at that boundary point. And we know that our two functions that make up this piecewise function are continuous because it's a quadratic and a linear function. Those are both continuous functions. So we just had to check out that boundary point. Okay, and a is equal to 26 makes it a continuous function.